ಹಲೋ ಸರ್, ಇನ್ನು ಯಾರು ಬಂದಿಲ್ಲ, ಬರೀ ಕೋರ್ ಇಸಿ ಟೀಮ್ ಅಷ್ಟೇ ಐತಿ. ಚೇತನ್ ಸರ್, ರಾಕೇಶ್.
ಗುಡ್ ಈವ್ನಿಂಗ್ ಸರ್. Suppose sir, you start the session, right?
Yes sir. Wind up ಅಂದ್ರೆ ಹಲೋ ಸರ್.
Yes sir, tell me.
ಇವಾಗ ವೈಂಡ್ ಅಪ್ ಅಂದ್ರೆ ಅಷ್ಟೇ, ಐ ಥ್ಯಾಂಕ್ಸ್ ಟು ಅಂತ ಹೇಳಿ ಓವರ್ ಟು ಪ್ರವೀಣ್ ಸರ್ ಅಂತ ಕೊಟ್ಬಿಡು ಅಷ್ಟೇ ನೀನು. ಕೊಡೋದು ಅವ್ರು ಏನೇನ್ ಹೇಳ್ತಾರೆ ಹೇಳ್ಕೊಳ್ಳಿ.
ಓಕೆ ಓಕೆ ಓಕೆ.
ಈಗ ಬರೀ ಸರ್ 3 ತುಂಬಿರೋದು ಇದನ್ನ ಅದು ಅಕಾಮಿಡೇಷನ್ ಬೇಕಂತ.
ಓಕೆ.
ಅವ್ರಿಗಷ್ಟೇ ಕೇಳಿದ್ರೆ ಗೆಸ್ಟ್ ಹೌಸ್ಗೆ ಬರುತ್ತೆ.
ರೈಟ್ 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 ರೈಟ್.
ಅದೊಂದು ಲಾಸ್ಟ್ ಒಂದು ಕೇಳ್ರಿ, ಏನಾರ ಡೌಟ್ಸ್ ಇದ್ರೆ ಕೇಳ್ರಿ ಅಂತಂದ ಫಾರ್ ಆಫ್ಲೈನ್ ಸೆಷನ್ ಅಂತ ಒಂದು ಲಾಸ್ಟಿಗೆ.
ಓಕೆ ಓಕೆ ಓಕೆ.
ಅವಾಗ ಏನಾರ ಕೇಳಿದಾಗ ಹೇಳೋದಕ್ಕೆ ಹರಿ ಸರ್. ಫಸ್ಟ್
ಸರ್ ಹೇಳಿ ಸರ್.
ಫಸ್ಟ್ ಫೀಡ್ಬ್ಯಾಕ್ ಲಿಂಕ್ ಅಲ್ಲ. ಹಲೋ, ಫಸ್ಟ್ ಫೀಡ್ಬ್ಯಾಕ್ ಲಿಂಕ್ ನ ಕಳಿಸಿ. ಆಮೇಲೆ ಇದು ಕ್ವಿಜ್ ಅದು ಈಗ ಮೇಡಮ್, ಈಗ ದೀಪಿಕಾ ಮೇಡಮ್ ರೀಸೆಂಟ್ ಆಗಿ ಮೇಲ್ ಮಾಡ್ಯಾರ ನೋಡ್ರಿ. ಆ ಲಿಂಕ್ ರೀಸೆಂಟ್ ಈಗ 6:40 ಮಾಡಿದಾರೆ. ಆ ಲಿಂಕ್ ಅದು ಸೆಕೆಂಡ್ ಕಳಿಸ್ಬೇಕು ಅದನ್ನ. ಅದು ಚಾಟ್ ಬಾಕ್ಸ್ ಅಲ್ಲೇ ಕಳಿಸ್ಬಿಡ್ರಿ.
ಸರ್ ಫೈನಲ್ ಕಳಿಸಿನಲ್ಲ ಸರ್, ಫೈನಲ್ ಲಿಂಕ್.
ಮೇಡಮ್.
ಓಕೆ ಸರ್.
Good evening, Arun Nair, sir.
Good evening.
Sir, we will wait another 5 minutes, sir.
Sure.
One information to all the participants. Today is the last session for online. After the session, we are conducting one small valedictory in that our convener will address to all the participants. After the valedictory, we will send 2 links. One is for the feedback, another is for the online test one. That is uh, uh, quiz we are conducting. Okay, feedback link and online test link we will share in the chat box only. Okay, so only FTP registered participants are informed to submit both feedback and quiz. Arun sir, shall we start, sir?
Yep, I'm ready.
Okay, sir. Good evening to all. First, I welcome our resource person Arun Ayers for the today's session. Welcome you, sir.
Thank you.
And also, I welcome all the participants for the today's session. Welcome you all. I request Arun Ayers sir to carry the session. Over to you, sir.
Thank you. So I'll get started. Just for a quick background or maybe some information for the audience. So as some of you who attended yesterday's session may have heard the interaction which I had with Dr. Praveen, where I think one of the inputs he specifically provided was to focus on open source EDA tools and flow aspects for today's session, and I think have that as a main focus item. So we had some specific agenda which I had shared yesterday. So I have updated the plan, and then I'm going to cover open source EDA tools and flows. In addition to that, I'll also talk about some recent initiatives taken by the academia world over, where with the support of Google and a company called Skywater, it's possible for individuals to design their own ASICs. So I'll also touch upon that. So that should be a very interesting, that's a very interesting development. I think it's only been last 1.5 years or so since this has taken off. And I would urge the master's students, bachelor's, or even PhD students who are probably in the audience, and the faculty members to explore that and come up with a plan to how you can explore those options and go ahead and see if you could get your designs implemented on the Google Skywater, test chip methodology, and then the flows. So I'll cover that, and that's on the last few slides. I'll talk about it, and I think we will take it from there if there are any questions. All right, so let me start sharing my screen. So my screen is just been shared. Let me know when you all can see it.
Yes, sir. It's visible.
Okay, thank you. So let's quickly go back. So this is the focus item for today's talk. I'm going to talk about some of the open source EDA tools available and the flows and the specific aspect of making your own chips, how it's possible. So normally you would think that making your own chips is something which is beyond what people can do in the academia or even individuals. Probably there's no scope. It's the whole process is very skewed towards industry and or maybe or to universities which have a lot of investment made in terms of the way, let's say, design infrastructure, or having some well-renowned faculty and so on. But it's actually not the case. Over the last 1.5 to 2 years, there's been a steady and a very sustained investment and focus made by companies like Google to get individuals to be able to build their own ASICs. It doesn't need to be a full-blown CPU. Even very small, simple controllers, very simple functionality could be implemented by them, and they could ship it to the foundry, and the foundry could, when I say ship it, I mean the database, and then the foundry could integrate the design on the test shuttle. Test shuttle basically means you have a wafer where multiple different designs could be implemented, and then the foundry, through this intermediary, which is the Skywater, and another company called eFabulous, which can then give your chip back to you. You could come up with your own test plan for the chip, test it out. It's very interesting, and it's very exciting for people to have this opportunity and this power to actually be able to build their own designs. And so I would urge that you should read more about it and start planning it out and explore. So let's before we get into that, let's talk about. So I think over the last few years, few days, we've been talking about the importance of EDA tools. I talked about how complex VLSI design is just not possible without software, right? Specifically, which for analyzing, running simulations, for doing measurements, and probably getting your database ready to send it to the foundry. All those things are are not done manually. It's just not practically possible given the complexity of the designs, the technology. So everything is supported and done through the EDA tools. And so I mean the EDA tools generally, when people talk in the academia, they only know about Cadence and Synopsys, which are companies which obviously charge a premium for the CAD tools that they sell, right? And they don't really have good quality EDA tools for students and universities, unless the universities can afford or they have a tie-up with the company, right? So as I was saying, this whole open source chip design, open source hardware movement has significantly picked up, and there's been an initiative driven by University of California, San Diego, and a couple of private companies to actually start writing open EDA tools, which are mostly free tools, and they are fairly competitive for you to be able to build your designs. And the flows, the tools can support various aspects of the flows. For example, synthesis. They can do placement, routing, clock tree design, and even do STA, timing analysis, and then be able to take the database, make it ready to be send it to the foundry. So I'm going to touch upon a lot of these EDA tools in the discussion today. So let's talk about so these are the three items I'm going to cover. Circuit simulation tools, front-end simulation tools, and the physical design tools. There's not going to be any break today because we just have a 1 hour session. So we'll try to take it through the full 1 hour, and hopefully it's an interesting talk today. Hopefully better than yesterday, because I found no engagement from the audience. I don't know that that's something which was a problem from my end, where I probably did not get a chance to explain it properly, or just that the topic was not very clear to the audience. So let's hope that this discussion stimulates the audience to explore chip design on their own using these free tools. So quick, how do you go about it, right? So what did I do? Even though I'm aware of a lot of these things, but for the sake of this presentation, the first thing I did was I searched on Google, give me some free open source circuit simulator tools, right? And I got a Wikipedia page. So this could be the easiest thing which you could do. Search for it online, and you should get a lot of circuit simulator tools options. Not all of them are good, or not all of them are active anymore. Some of it could just be historic, or some of them are not being maintained well to keep track of the latest technology nodes, or to get the bugs or the software bugs in the tools resolved, and so on. So what I've done is I've taken this table from Wikipedia, gone through these specific circuit simulator options, and I've chosen a few which are very actively being supported and seem to be in a good shape for the audience to go and explore. So the first one that I found for circuit simulation is SPICE tool, an open tool called ngSpice. I think I touched upon this on the first day, on the first day as well. So ngSpice, you can search for it online directly. Is an open source, or you can go to the Wikipedia page, either way, right? So the ngSpice is you can sort of read through it, is an open source SPICE simulator. SPICE is essential for circuit simulations. You can't do without it. So if you want to do an analog simulation, which means you want to look at current voltages, you want to look at power, you want to actually look at the waveforms, you want to do a small signal analysis, large signal analysis, frequency domain, time domain, AC analysis, right? Whatever you want to do, which you study in your circuits, network analysis concepts requires a circuit simulator. And SPICE is the standard for the VLSI industry. But there are multiple different SPICE versions available. This freeware is ngSpice, and it seems to be fairly easy to install. You can go to the website, and there are a lot of there's a download option. You can directly download the executable. And if you have a Windows machine, download it on your Windows machine. If you have, if you're in your lab and you don't have SPICE, you can probably talk to your, excuse me, you can talk to your IT in charge for the lab and ask him to download a version which is compatible with maybe Linux or any operating system that you have in the lab. Ask him to install it on every machine, and then start exploring it. Read the documentation, run through the tutorials, and try it out. So without trying it out, nothing works, right? That's the most important thing. So these tools are just the getting started with things, but finally it has to be tried by you. So this is like a very simple tool. I tried installing it, it works, and I tried running some simulations. It seems to work fairly easily. If it's not clear, try out the tutorials out, go from very basics. They would have some simple examples for inverters. For example, this waveform in the tutorial seems to be for an inverter simulation. You can just see this here. They're given a SPICE example here. An inverter is designed. You may have to write the simulator using SPICE syntax, which I would suggest that you should learn. It's not very difficult. And you can clearly run simulations and see the waveforms. And as I said, it has multiple versions, Windows, Linux, if you want to install it in your lab, which usually have Linux machines. And then you can, it sort of gives some examples. Looking at transient simulation, which means time domain simulations. You can do an AC simulations, which means as like a frequency domain simulation. And you can run a lot of other things. So go through the tutorials. There are a lot of details given here. Spend some time and start testing it out. I would suggest if there are people from in the audience who are probably in the third year or who are interested in doing working in the VLSI domain or want to do some projects in circuit design domain, to actually go through it systematically, open your textbooks. First, obviously, you have to learn some of the SPICE syntax, but hopefully, if that's not difficult, a lot of documentation for that is also available. And what you could do is open your textbooks, see some circuit there, and you want to understand it by running simulations yourself, build it, as shown in this case for the inverter, but you can do it for some other circuits also, maybe some complex gate, and you can look at rise time, fall times, propagation delays. You can look at, for example, if you want to study short circuit currents, you can, as we discussed yesterday, you can look at that. And a lot of things could be done by you. So the space to explore is completely in your control. You can talk to your faculty, talk to your lab assistants, get inputs from them, get guidance as to what you could run, and start doing it. Just get started. I think you should be able to pick it up quickly. So this is ngSpice. And then another tool for SPICE is pSpice. So pSpice, interestingly, this specific version called pSpice for TI is very interesting because this is now actually being supported by Texas Instruments, which means the quality of this SPICE should be extremely good because TI is directly involved in supporting this tool. Why is TI supporting this tool? And what is different between maybe ngSpice and this? One is that so pSpice on its own is probably not very different than ngSpice. Just that you have two different softwares, and the people who may have written the software or maintaining the software could be different. But the interesting thing about pSpice for TI is that it is specifically designed for a lot of the ICs which TI designs, and which means if you have a TI chip, not a very complex one, but let's say simple one, things like some transistor logic-based logic or TI's own voltage regulator or some ADC or DAC or anything like that, if it's available as a chip or a system, TI provides a model for that, which means if you want to use that, and let's say you're building some breadboard and you use some TI chip, So it's possible for you to look for that TI chip model in this setup, and you can directly call that in your simulation, and you can directly replicate what you need to, what you would observe in your breadboard or in your system level board level simulation. You can run it in PSpice. That's the beauty of it, because you could now directly call that component, which is from TI, and you could have that model. It'll have its input port and output port, some power supply requirements. You can set it up in the simulation, and you could then trigger it, and it could generate some results, which you could then use using the rest of the circuits that you may build and so on. So that's one of the good, the advantages of it. I think it only works for TI components. You may not be able to use it for, let's say if it's something you're getting from ADI or something you're getting from some other company, may not be possible, but still it's sort of a very good tool. And you can always run basic SPICE simulations on this. So nothing stops you on that. So whatever, or the approach I talked about with ngSpice could always be done here. And then there is a lot of details about the technical documentation is here, training and support. There are some labs available, videos available. Go through that. It'll be a slow, steady process, but I think it'll be worth the investment that you're going to make in understanding or using these tools, especially if you want to do some projects at your end. So try it out. Another tool is called TINA Spice or TINA Circuit Simulator, and TI again has specifically created a version of it for its own chips. TI's op-amps and other complex system level things could be called as models, as shown here. For example, TI it also has a GUI, which means you can do a pick and drop. You can pick the component from the GUI, click on it. Let's say you pick a specific op-amp from TI or some ADC or DAC, and you can plug it in, and then you can create a full system. For example, for an operational amplifier, based on whatever circuit you want to build. You want to build an integrator or a adder or a voltage scaler or whatever you want to do, right? Which you read in your textbooks. You can try to actually do it in the simulation here. So I would actually suggest that people should just open the textbooks, start doing them, some of the circuits given in your textbook, and building them on your own. First thing is obviously you have to understand the concepts, because without that, simulation is useless. Simulation is only going to give some neat waveforms. For you to understand what's going on, you need to have some conceptual basis, but to be able to then explore and try some projects at your end, you can start using these tools. So yeah, basics are important, but I think once you are comfortable with the basics, start using these tools and try them out, and try out things which are given in textbook, and whatever papers you may be reading, and start trying out things, and it should be very interesting, given these tools are providing a lot of complex functionalities. Some complex chips are being modeled here, complex simple components are being modeled here. So you should be able to do some fairly interesting analysis. And if you want to do some projects, again, talk to your faculty, talk to people from the industry if you are in touch with them, or your lab assistants, or just that your friends, like what projects they may be planning out, and you could work together. So we covered 3 circuit simulator tools. Let's see, there's another one called KiCad. KiCad is not just a circuit simulator. It has a SPICE simulator and a GUI available, but also what's interesting is you can actually build a board level design out of it. So I've not explored this tool, and I actually have not worked on PCB layout. But let's say if you are trying to build some simple board level thing or a simple PCB functionality, this tool allows you to, this is a free tool again. It allows you to do a schematic capture, which is, I think, a lot of the other tools are also giving you. So which means you can draw schematics, but you can also actually do a PCB level analysis. PCB layout can be drawn by this. And then the PCB layout, once it's drawn by you, could be, then you can generate an output file from this, which could be then given to the company which may be able to design the PCB for you. So so in case you are interested in exploring that, this is again an interesting tool. So which means it's not just the a chip design part of it, but you can also look at board level or system design aspect here. So go through it, explore this out, and let's see if you have any questions for what I covered for circuit simulations. Maybe if you have any questions, let's talk about it. Yeah, feel free to type your questions or unmute yourself and ask any questions that you may have for what we talked about is open circuit simulation tools. Sanjay, you want to unmute yourself and ask the question?
So what are the open source tools for designing the front end, digital design, so digital electronics?
So when you say digital design, what specifically do you have in mind?
I mean, in terms of logic gates, sir.
So logic gates in terms of transistors, or logic gate in terms of just the logic functionality?
Yes, sir,
High,
logic
low?
functionality, higher abstraction level.
Higher abstraction level. Okay, good. So I'll come to that. That's the next item I'm going to cover.
Okay, sir.
But if you want to build some functionality or you want to explore some circuit level things, for example, you can even build CMOS logic gates, or if you want to do some analog circuit simulations, you can use these tools. Even digital circuit simulations are possible. You can build bit cells, memories, you can build flip-flops, you can build logic gates. I showed some simulations to run for flip-flop characterization, logic gate characterizations, if you remember. All of those things could be done using these circuit simulation tools. So that's something which could be explored. If you want to go to higher levels of abstraction, I'll come to that. That's the next item I'll cover.
Yes, sir.
Hello, sir.
Yeah.
Any open source tool for physical design, PD?
Yeah, I'm going to come to that.
Okay, sir.
I'll talk about that. Yeah.
Okay. Is that open source is similar to what we have the Cadence tool? Is the same features or is there any difference in that?
So if you already have Cadence tools, then I don't think you need to worry about these open tools. But I think the open tools are useful. Let's say after you leave college, and let's say for some reason some of you did not get a job in the VLSI industry, right? And you still want to learn the tools. So how do you do it at home? So some of these tools could be useful there.
Actually, in my college, we have gotten a Cadence tool. So in that, we have got a Innovis and Genesis. We using that, but at home we don't have any. That is, we don't have any permission to use. So that's why I asked, is there any which is similar to open and that one? That's why.
So these tools will be similar, but they will not be exactly identical because those tools are proprietary. Proprietary means they are not open. So which means some of the commands those tools are allow you to use, some of the features they may have could be different. But it doesn't matter as long as you want to understand the concepts. So I think one of the advantages of these open tools could be that you can actually do projects yourself at home. And even if you, let's say, leave college and let's say you did not get into the VLSI industry just after college for some reason, right? Let's say you did not clear the interview or you did not get a chance to attend the interviews, any reason. So you still want to, let's say you're seriously interested in pursuing opportunities in the domain. Do you give up or do you? So you can use these tools, try out things at your end, and maybe capture that in your on your website, like GitHub page or your LinkedIn page. You can say I did this project, so that these tools provide you the opportunity to do that.
Okay. And one more personal question is that company need the certification course? Because when I attended 4 companies, they kept it in my this thing waiting list, and they suggested that after 10 years of experience of teaching, so you don't have any industrial exposure. Is that certification? If you have any certification, is fine. They asked. So is the certification is mandatory to go into and realize a company as the 10 years of teaching experience?
To be honest, if you ask me, certification is junk, is of no use. It's unless you do some project, right? So I think the whole thing which matters is when you attend the interview, you should be able to answer the questions. If they ask you specific aspects of the design process, or ask you some concepts, or ask you to design something, let's say on the board, or give you a problem to design. Let's say they can give you a problem to work over the weekend. There are multiple ways interviews happen these days. So it could be anything. So I think the important thing is to actually have the skills to use some of these tools, have some exposure in designing things. And I think I'm going to talk about how you can even go ahead and design your own chips, which means if you're in a college as a faculty, you can even work with your head of department and some of the senior faculty members there. You could work together with them, come up with some project which you and your students could design, and get a chip back, test the chip, and maybe write us a small paper, which could, if not it could be published in, if not a global, a very known conference or a journal, but certainly maybe some internal journals or some Indian journals, or some, just to get started with the process. I think once you start doing that, things will pick up. So don't worry about this whole certification part, because finally people test based on interviews only. Certification has no meaning that way.
No, they ask it like that only, sir. That's why I asked. You don't have any industry exposure. At least you need any, because we are training the students in a cadence tool only with that tie up with the Vivartan Technologies and Finance Tech. So we had some of the tool exposures, but they asked for certificate. That's why I asked, is that course is mandatory? Because 3 of my friends did the course and they, so that's why I got and confused about it. Is that mandatory or like that?
No, they may have done. See, they may have done the course, but finally they must have learned some skills, and they must have been tested for those skills, and they must have done that. They must have cleared the interview based on the skills they were the questions they may have asked, or the skills they may have been tested for. So finally, the certification on is just, maybe certification may allow you to get an interview call, but finally the whole thing is based on interview process.
Okay, sir. Thank you.
Yeah. So Anita, you asked what is the difference between Spice and PSpice? Spice is basically the actual circuit simulator, or the actual language in which you write the circuit simulation setup. For example, if you go back to this page here, this syntax that you're seeing, this specific thing, this is written in the Spice format. PSpice is a simulator. It takes Spice inputs, or circuits written in the Spice format, and it takes this and it runs a simulation. So in this case, this is ngSpice. So the underlying setup is Spice, but it's a simulator. So this is a simulator. For example, you have Model Sim. Model Sim can run simulation on Verilog or VHDL. So Model Sim is not Verilog or VHDL. Model Sim is a simulator. Same way PSpice is a simulator. But the input it takes is going to be circuits which are written in the Spice format. So ngSpice is a Spice format, Spice simulator, PSpice is a Spice simulator, and so on. This TI is again a Spice simulator. And this one again, KiCad can do a Spice simulation, which means you have to just define the circuit in a Spice syntax. Hopefully that answers your question. Okay, so let's move on. So this is good. So let's talk about some open simulators for or logic simulators. So there can be logic simulators for Verilog, for VHDL. And if you search for it online, the Wikipedia page shows up this table. There are a lot of, as I said earlier, for the circuit simulators, there are a lot of different options available. And I have trimmed it down. I think I could actually see only 1 or 2 which seem to be very relevant or useful. But you can give a try yourself. Maybe I did not cover all options, but one very good option open source simulator that I saw is called Verilator. This is an open source simulator, and it can run some. It can read a Verilog based netlist or an RTL, and it can do a simulation. It can also do on system Verilog. System Verilog is a variant of Verilog, which is usually used for test benches and verification. And so what's interesting is it's not just some open source tool sitting there, and only people who cannot afford to buy Cadence Synopsys tools are using it. But if you notice, this specific simulator is actually even being used by some of these companies, some of the really well-known ones. We have ARM here, we have Tesla, which the Tesla's VLSI team, AMD seems to be here, I think Microchip is here, Western Digital, which designs a lot of these flash memories and other systems. So a lot of these, even the commercial usage is there. And what these guys are claiming is that the performance of this simulator is significantly faster than even the ones coming from these big two vendors. So obviously, if you understand big two, you know which two vendors they are talking about here. So the performance of this is even better. So I think it'll be great if you give this a try. So again, you have to go to the website Verilator and check how to install this, and try to follow the documentation to install it at your end. And if the documentation to install it seems complex, maybe take your IT person's help and ask him to help it install on the lab machines, and maybe just follow the same instructions to try it at your end at home on a laptop or desktop. Okay, so I think that's the only sort of interesting open source RTL simulation tool I found, but there are other options. I think this Icarus Verilog is also one which seems to be supported and used by quite a few people. I actually could not go to its website, and I had some trouble there, but you should give this a try. This is another one, which is an interesting open source tool, and it's also fairly well supported. Notice, so for you to decide which simulator to use, notice how or how frequently the tool is being updated. So if you notice, this one supports Verilog 1995 version, Verilog's 2001 version, 2005 version, system Verilogs, so many versions, which means this tool is continuously getting updated by the author or the company supporting it, which means this is a high quality tool, or it is something which will have less number of bugs, or it is compatible with the latest updates in Verilog. So it'll be good to give this a try. Similarly, Verilator, again, as latest as System Verilog 2017 is being supported. In any case, I think as we saw for Verilator, even commercial companies are using it, which means this must be a high quality tool. And there are a few other ones. Some of them are fairly old and looks like they're not undergoing any active development. But I think you should probably check it out, and in case you have some struggle with Icarus Verilog or Verilator, maybe you can check the other ones. Okay, so any questions on these RTL simulator options? So Ms. Chaitra is asking how System Verilog can be related to VLSI design. System Verilog is used for it's used by a lot of companies these days. I see that in my company and in a lot of other places that I worked. System Verilog is frequently used for running verification, writing test benches, and it is very frequently used by front-end people for doing that. So System Verilog is something which is an add-on over Verilog, which is having a lot of C constructs are there. So which means a lot of people who have a programming background can actually be comfortable with it. So it has Verilog and it has some C features as well. I have not worked on this, so I can't give you details about this. So maybe you should talk to, if you're looking for inputs, I mean, if there are people who know about it, maybe you can send a note to people on LinkedIn, or try to search for it online to understand how different is system Verilog from Verilog. But I do know that it is used for verification and a lot of test bench creation. Front-end teams heavily use this, and it is right now, I think, the standard for front-end.
Okay, sir. Thank you. Sir, can Verilator can be used for that system Verilog?
Yeah, it says here, right? It accepts Verilog and system Verilog, so you can just give it a try. And I think if you know some programming also, it probably has some hooks to probably even code in C++. And you can just check this out.
Okay, sir. Thank you. Thank you so much, sir.
Any other questions on RTL simulation related aspects, or netlist simulation related aspects? These front-end tools, these are primarily used for logic simulation. So I want to distinguish between logic simulation and circuit simulation. Circuit simulation is actually looking at the analog aspects or real circuit aspects, current, voltage, power, whatever you read in actual circuit aspects, right? So network analysis, your electronics concepts. Whereas logic simulation is just it doesn't care about the actual analog behavior. It only cares about logic. So which means you just see 0-1 type kind of transactions and operations. So it is primarily a digital design sort of analysis, abstract analysis. Any other questions on this one? If not, I'll go and start talking about the physical design flows. Okay, so physical design flows have been very interesting, and there's been a really interesting development which have been happening over the last 1.5 to 2 years. Really interesting developments, and it's picked up significantly, especially after these initiatives which I'm going to cover: open road, open lane, and I think eFabless. So physical design is basically the process of actually taking your behavioral RTL, right, and synthesizing it. So once you have an architecture, we talked about the actual flow, right? You have an architecture. We have then the architecture is then converted into an RTL, which is basically a behavioral description of the architecture in Verilog or VHDL or even system Verilog, and then you want to then take it through the actual physical process, which means you want to map the behavior RTL into gates, and then that is synthesized, and then synthesis then takes it to actual. You want to build it in a chip, which means you need floor planning. You do placement of those gates in some area. Then you do a synchronous design, which means you need to distribute clocks to those sequential elements of the design. You then have to route it, which means you have to actually do a pin-to-pin connectivity has to be done for all the gates in the design. Otherwise, obviously, signals will not flow. And then you have to run extract, which means you have to find get the parasitics values out, and then you should be able to run timing analysis, static timing analysis, as we discussed yesterday. And then once that is done, your chip is basically, if it's meeting the spec timing wise and power and whatever, then you can then take it to something called as a physical verification flow, which means you are now checking whether the physical implementation is similar to what is its logical behavior, and then you can try to meet the boundaries design rules requirement, which means Foundry says that certain gates and certain nets and certain wires have to be built in given set of constraints which the Foundry imposes. So as long as those rules are met, then the chip is ready to be taped out. So physical design flows are essential for you to have a real chip and be able to send your database to the Foundry where the Foundry actually fabricates. So this was one of the major bottlenecks for people to be able to build their own chips, and because these tools are extremely complex. We're talking about lakhs to millions to now billions of transistors, right? So that scale of complexity, no open tools were available at the time, and we're talking about for the last 10 years. But things have picked up significantly, and there have been initiatives done by certain universities, specifically Open Road is one of the open physical design flows. It is like it's basically a physical design flow. So physical design flow means that you have multiple tools at various stages of the physical design flow: synthesis, placement, clocking, routing, and the physical verification. All of them are put together, and it's not like each tool is independently has to be run. So flow means that this specific Open Road initiative gives you a full package where there will be some additional programs or simple, which are called scripts, which are written by which you could pass your input and it will take it through multiple steps or all these steps and give you an output, which would be like a database ready to send to the Foundry. Or it will say that the step failed at this point, which means, let's say you have some problem in the design, you have timing issues, or you have let's say some physical database issues. For example, your floor plan is bad in some way, so you can run an end-to-end flow, and you can also sort of get feedback of how some of those steps have have been run, and whether the results of those are meeting the requirements or not. So this is one of the great aspects here. So it's a flow means that you don't really have to worry about how to integrate each of these tools separately into your runs. So that's done by Open Road. And so you should try going to this website. So very detailed presentations are here. It has I think a very detailed GitHub page, and it also describes what are the tools available. So I went to the GitHub page. In fact, I'm aware of this specific Open Road initiative because I've been tracking it for the last 1.5 years, and it's really has come up significantly. A lot of universities have shown interest and started using it across the world, even in India. I think there are people who are now providing training for this. So I would urge the faculty and the students to explore this and plan the usage of this. So there are a lot of different tools. For example, if you want to do synthesis, what is synthesis? Synthesis is basically taking an RTL and convert that into gates by reading the library. So logic synthesis is possible, and you can do some synthesis level optimization by this tool called YOSYS. It's an extremely capable tool. It's been there as an open tool for almost 10+ years, but it was not getting attention because of all the reasons I described, because people just did not care about synthesis standalone. So once you generate an output from this, it had to be compatible with other aspects of the flow. So now with Open Road, we have been able to integrate YOSYS with other flows, the files that you need to give to YOSYS, or what files YOSYS generates, which are taken up by other next steps. All of that is now ready, and it's been used, and it's been the whole end-to-end steps can run cleanly. So you can use YOSYS. There are other aspects, other tools in the database. One for placement, one for clocking. So go through this. I didn't provide all the details of the tools which are here, but I think it's like a very well maintained database. And in fact, the US organization called DARPA, which is responsible for a lot of innovations which happen in the VLSI domain, funds this project, and their whole motive or the goal is, read this, Open Road, its objective is it seeks to develop and foster an autonomous means on its own. That means it should be like a fire and forget. You give the inputs, it should be able to run on its own 24-hour open source layout generation flow from RTL, which means your behavioral RTL, to GDS. GDS is basically the database which has the mask information which is sent to the foundry for the chip to fabricate. So RTL to GDS. So the whole goal of this project is to allow end-to-end integration of all the tools and be able to run this in 24 hours. Usually the whole end-to-end RTL to GDS steps in the industry takes near, also keeps repeating multiple times. So in a sense, RTL to GDS2, if you're able to do it in 24 hours, as this project seeks to do, that will be an excellent accomplishment. And if the industry, if the universities and students like you, faculty members like you can start using this, provide them feedback, I think this whole dream can be realized. And they have done a great job over the last, and there have been individuals and universities from other parts of the world which have tried using this, and they've been fairly happy with the support they're getting here. So this is an extremely well maintained and an extremely active project, specifically driven by University of California, San Diego. Another one is OpenLane. OpenLane came about, I think, just at the same time or before, or probably a year before Open Road. So now Open Road has now taken up and even supporting OpenLane tools and OpenLane specific flows. But if you still want to go ahead and read about OpenLane again has its own GitHub page and its own set of documents. So a lot of, again, a very well maintained one. It is supported by a company called eFabless. I'll come to that. So it is again it's actually having a commercial company which is supporting it, which means there's going to be a good amount of focus in maintaining a good quality here. All the tool issues, bugs, all those things will be sorted out. So again, go and check out OpenLane. So any questions about these PD tools and PD flows? Any questions? There was someone who was asking about open PD tools available. Any questions on this? Okay, so let's continue. So the next thing I want to highlight, and this is probably hopefully excites a lot of you. It certainly excites me because this whole there's this initiative which is being called as democratizing the chip design. Obviously, I assume you understand what that means. Democratizing means it's accessible or available to every individual, whether it's in a big company or a small company, in a big university, small university, right? In an individual. So you have the power now to be able to design your own chip. Obviously, what goes without saying is that you need to have the skills to be able to do it. But there's no stopping you if you have the skills and interest to pick up those skills and to be able to build your own chip and test it. So it doesn't need to be a very complex chip. For the level of skills that you have or what you want to test out, you can build a very small functionality, some complex functionality, and so on. So this whole process is being supported by this company called eFabless. I talked about this open lane here. So open lane is now basically being supported by eFabless. Open lane, because now it's also being supported by Open Road, which means Open Road again has a tie-up with eFabless. So you can go ahead and build your own chips. So there's a very active website for this company. I just took it from the web page. Read about this. So Google is sponsoring this. And there's something called as an MPW. MPW means that they have a test chip. So they have a big wafer, and on which multiple different chips from different companies, different individuals, different universities could all be put together, and they could all be, they can all share the cost of getting the chip on that wafer, and the cost is fairly affordable. It's affordable, and you should just check it out, especially if it's universities. You want to see how much it costs you. If you want to, let's say your students are building some design, and you want to expose them to chip design process, you should check it out. I think it's fairly affordable. And if you want to have lots of chips from your universities or small companies or individually you want to do, it's I think you should check the cost out. It's not very high, and because Google is subsidizing this, and so as it says, make your own chips for free. So design and fabricate your own open source design for free with Open MPW program. MPW means you are sharing the wafer space between multiple other people who are sending their designs, and you could have your own chip fabricated on that wafer. And for I think this is for this year. So they have another test shuttle coming up where you need to submit your design by September 12th. And in case you're interested, over the next few months, pick up some skills, come up with some design, and try to see if you can follow the process of the flows given here and have some of your design implemented, send it out before this September 12th to eFabless. So you may have to go to the website, register yourself, and then come back, learn these flows and some of these tools given here. That's sort of the easy part. A lot of documentation is here. And then get your design out to eFabless for fabrication. So the actual fabricator or the for company which is the foundry is called Skywater, and then Google is funding it, which means almost no cost for individuals and universities looking to do this. And eFabless is setting up and supporting all the tools and the flows. And they have a dedicated set of teams to support people to be able to do this. What is their motivation? They want this whole chip design process to be democratized, and they believe that once they do this, they can go ahead and people can build a lot of interesting functionalities and interesting features on silicon, which is very low cost, and don't need to go to big companies or to large foundries like TSMC or global foundries to be able to build the chip. Now, these MPW funded by Google and sponsored by Skywater could be the approach where a lot of these simple designs and not very complex designs could all be built. People could prototype their design. If you have a startup idea, for example, you don't need to have millions of dollars to be able to get a chip out. You can actually use this approach to be able to building to TSMC or Global Foundry. Maybe you can show your chip to the customer, customers, and say that you have a viable product. So that's basically the whole motivation for eFabless to be able to do this. And that's like a very noble, I think, motivation here. And their intention is extremely noble. And I think it's something which had to happen. And this whole initiative has picked up significantly over the last 2 years. So how does it happen? So you could have your own design like this. Even though this design is showing some complexity here, it could be a fairly simple design. Let's say you could build some very small controller, some simple to complex state machine, and let's say you want to test it, you could put that in your design. How does it go? It sort of sits in a space which looks like this. you are slot and interface with your logic to be able to test them, right? Because finally it has to be tested along with the template, then becomes a whole chip which gets fabricated, and from your side, which means you're going to get this hardened chip, and then any questions here?
Participants are requested to ask any queries, any questions, any clarifications if you need. This is the time to ask. Anybody?
Was my when I was explaining this, talking about eFabless and this flow, was my voice audible? What did people get the points I was trying to make, or do I need to repeat it? Was I audible during that part when I was trying to explain that or talk about it?
So our voice was breaking, sir. So we couldn't get the points later.
At which point was it breaking?
Sir, this we were clear, sir. Before to this, you were explaining about the chip design, no, sir.
Which one? Which one? This one?
Yes, sir.
Yeah. So here, as I was saying, there's a company called eFabless. This now is being supported by Google, and there's a company called Skywater, which is the foundry which will fabricate the chip. So eFabless is facilitating chip design from all people, whether they're a large commercial company, a small company, universities, individuals, and it's mediating and it's setting up a lot of the backend aspects where people can interface with them, and you can build your own designs through this approach, where you can have your own design. Could be a simple design, a complex design. eFabless gives you a template where they give you some space and you can put your design here. eFabless also provide you some in the chip, some infrastructure to be able to test your design, because otherwise what's the point in putting a chip if you can't test it, right? And then this becomes the overall chip that the individual gets. And this can then be tested by you, and then, or you could put it in a board and then have a more complex system built. So that becomes the whole thing. And this whole thing is nearly free, is for individuals, for universities. I would urge you all to just go and check, go to eFabless webpage, read about it, and maybe talk to your faculty members if they are not already aware of it, and maybe plan it out. So they seem to have a deadline for September 12th, which means the MPW means on a wafer, multiple chips can be put, where the chips could be coming from multiple different places. Some other universities, small companies, individuals. So So that whole thing is being done. So this MPW 7th version of it is happening, and it seems to be taping. Its deadline is September 12th. That's a lot of time. I think I would urge you to maybe just work with your faculty and HODs to plan this out, and maybe try to understand the whole process, learn the flows as we discussed, these two, open road and open lane, one of these. See the tools being used, understand all the physical design flows, understand other the open source tool to be able to analyze your design, test it out, and then once you're ready, try to build your own design based on the template that eFabless gives you, and then try to complete it before September 12th for this year, and get a chip back and have a way to test it out. So I think it's interesting. You should explore this. Talk to your HODs and faculty members. Okay, any other questions? So this is basically going to be the last slide I have. So FOSSEE is a free and open source silicon foundation. This is I think this one is a non-profit, which is specifically focused to ensure that the open source silicon initiative picks up and takes off, and it supports it. All these open lane, open road, eFabless, all these initiatives are tied with FOSSEE. So I think I would urge you to go and to the FOSSEE website, read about it, see all the information that they have. A lot of things are here, getting involved, some SOC related stuff, what projects are ongoing, what events they may be having. It'll be good to sort of try to understand what's happening. And it's very, very relevant for people who are in the universities, academia, to be able to understand what initiatives are happening in this area, and maybe get plugged in and gradually start maybe doing things in this area, for example, or build your own chips as discussed here, and so on. I think that's mainly it for today. That's all I had, and that ends our 6-day session. If do you have any questions specifically up for today? Any things to clarify for the items that I talked about, or any of the items we talked about over the last 5 days, 5 days before this? So Dr. Praveen, you want to add anything? I think you specifically wanted discussion on all these open tool aspects. Did this provide all the information you wanted, and does it help you?
Yes, sir. Yes, sir. Because
Okay.
yeah, most of the faculties and the participants, I think they are noted these open source tools. Let them go and search in the Google and let's study about it. Then they will get back to you, sir. If they have any
Sure, I think
queries or
yeah, I think the queries in any case will be supported by the lot of well documented, and they have their own mailing links. They have their own groups which you can try to mail and request for information. Documentation is very well there. So there are people who support it. They will have some contact pages where you can send it to the email groups, that the groups that they would support these tools and flows. So I think I would urge the audience to read and then contact them, and start gradually picking up things. It's not going to be a one-day work, but I think it should be a very fruitful exercise, and would allow you to gradually get an entry in this field. If you can do a project yourself, that will be great. Or if you can use some of these tools and so on.
Yes, correct, sir. Okay. Okay, sir. Can we stop here and can we start the valedictory for a few minutes?
Sure. Thank you.
Yeah. I request the coordinator. Yeah.
Sir.
Okay, sir. Personally, I thank Arunayar sir for his valuable time shared with us, and Now I would like to call our HOD, Dr. Pavin sir, to talk about online sessions, what we carried for these 6 days, and also to enlighten the participants regarding the offline sessions. Sir, over to you, sir.
Thank you, sir. Thank you, sir. So good evening to all. So first of all, the special thanks to the coach head, the limited, the Ankit sir, as well as the Arun Iyer sir. Okay. So initially we started this, the proposal in the month of, I think in the last 8 months back. So the proposal is accepted in the ACT Atal FDP. This is the second level of FDP we are conducting from the ACT Atal. The level 1, which was in the during the COVID time, we conducted in the online. So this is the second, the level 2. I think we got around 3 lakhs from this FDP online and the offline. So first of all, I requested to the Enterprise Technologies to carry the complete online offline session. They agreed and they supported during the submission of the proposals also. Then during the online, I requested to coach at CEO Aniketan. He's also agreed. They agreed to support for the online session. So with the support of Coach Ed and the Enterprise Technologies, we are happy to host this Atal FDP. So I thanks to once again, the Arun Iyer sir is spending a valuable time between 7 to 9 o'clock daily. Okay, it is harsh related, it is difficult for the even the participants and the resource person to spend such a time in the evening. Okay, anyway, thanks to Arun Iyer sir for the wonderful sessions you are carried all the 6 days. And also some of the participants are very active because at the end of the offline sessions, we have to reward some books, okay, IoT books to the best participants who are all the actively participated in this FDP. So already we have noted some of the active participants. Anyway, I thanks to all the participants and also the students who are joined from the coach head side for being a part of this FDP for all the 6 days. And also I thanks to the coordinators, okay, because at the right time they have to start this FDP. So they are taken the initiation and they started at the right time. And also special thanks once again to Arun Iyer sir, even his busy schedules, he started his session at the exact time, okay, and completed it in time. Thank you one and all for being supported for this FDP. Okay, so with respect to the offline, so offline session will start from a Monday. Okay, so initially there will be the registration counter. I request all the participants be in the institution in our organization at exactly at 9 o'clock. You have to register on the registration counter in the Department of Electronics and Communication exactly at 9 o'clock. So you'll get one conference kit. So after receiving the kit, you have to go for the breakfast. You have the breakfast. At the same time, we have a puja for our the lab, okay? Because I think 1 year back, I written a proposal to the Madroof scheme. Luckily, I got a 20 lakhs from the Madroof scheme. So the lab is completely set up, okay? So we wanted to do one inauguration in the lab. So we are planning to go for with the puja. So the puja, it is arranged at 9 o'clock for all the HODs and the management from our institution. So participants can join for the puja session also after registration. If not, they can directly go for the breakfast. You have the breakfast just beside our we have the inauguration hall. So you have to be in the inauguration hall. So from our side, we'll complete that puja before 9:30. And we also join for the breakfast. After the breakfast, exactly at 10 o'clock, we are starting this inauguration. So I request all the participants, okay, because the 80% of attendance, it is mandatory for this Atal FDP. So whatever the sessions you are attended from the past 6 days, everything we are entering into the on Atal portal, your attendance status, and also the same thing we have to maintain for the offline session also. So in this regard, I request all the participants, okay, so be exactly at 9 o'clock to the institution, okay, take the active participation and get the benefit out of it, how you are taken from the offline, okay. So I thanks once again the coach Aniketan sir. Sir, thank you very much, sir. Aniketan sir. Hello. And also I thanks to Arun Iyer sir Sir, thank you very much on behalf of the management, the principal, the Department of Electronics, and personally. Thank you. Thank you very much, sir.
Sure, Dr. Praveen. Thanks for organizing this, and I thank all the audience for being patient through the 6 days. And hopefully, this whole set of talks have been useful to you, and it triggers some initiatives in you to start getting venturing deeper into this field of VLSI. I look forward to meet some of you once you're able to do some interesting projects, and hopefully start working in the industry. Best of luck.
Thank you, sir. Thank you. Also, I thanks to all the participants. Okay. Because some of the participants, they joined from the other stage. Okay. Initially, when with this FDP we got, okay. So only the 50 participants was the limit. So we are not promoted in the local, okay. In the local Karnataka, we are not promoted. But when I saw the portal, I think all the 50 participants are registered from the different state. It is really shocked. Then we individually call for all the participants. Only attending the online, it is not possible. You have to attend for the offline. Then only the Atal will issue the, as per the guidelines, they issue the certificate. Then most of the participants, they're taken back. Then we promoted this FTP for the local Karnataka. Then most of those are really like to attend it for the offline. For them, we are given the approval. So finally, we got around 49 the participants. So I thanks to all the participants for attending this online and showing the interest. I expecting the same thing for offline also. Thank you for all the participants, and also the special thanks to my both the coordinator, Professor Sampath and Professor Arish, and also the Chaitra madam who done the MC for this. Thank you one and all. Arish sir, over to you.
I also thank you for organizing such a wonderful online session in these 6 days, sir. So hopefully we also join with you for offline session. There is an instruction for the participants. So already Google form feedback is shared in the chat box. Please.
Arish sir, one thing. Arish
Yes,
sir,
sir.
I want to add one thing.
Yes, sir.
Yeah. So participants, please fill the feedback. Only the participant has to fill the feedback form, because some of the students from the coach head, they joined all the 6 days. Don't fill any feedback. You the same link you can start from filling the feedback from tomorrow. Today, the feedback, it is open only for the participants who are registered through the Atal portal. Okay. So once again, I'll repeat. I request all the coach head students, don't fill the feedback. Okay. So only the participant who are participated are registered through the Atal portal. Those only fill this feedback. And also there will be a 30 MCQ questions. It is open till 9 o'clock. 30 questions, whatever the syllabus it is or the content it is covered in the 6 days, the same questions we are added. Okay. So this link will be open till the 9 o'clock. So after 9 o'clock, it won't take. So I request all the participants fill the MCQ question as well as the feedback before 9 o'clock. Thank you. Thank you, one and all. Over to you, sir. Arish, sir.
Sir, thank you very much, sir. Again, after filling up the feedback form as well as the quiz questions, I request the participants who are coming from outside, we are informed you to fill the Google form for the accommodation. We received only 3 participants for the request of accommodation in our campus. So if anybody else wants to have an accommodation in our college, please you have to let us know now itself, or you can contact us for the accommodation in today only, because we have to make an arrangement. So I request participants, if anyone else wants an accommodation other than those 3 participants who have filled the Google form. So if anybody else is there, please let us know so that we can make an arrangement for the same.
Excuse me, sir. Harish sir.
Yeah.
Sir, test link is shared.
Yes, pardon, madam.
Test
No,
link
madam.
is
No,
shared.
no, madam.
No, it is not yet shared, madam. It is not yet shared. Now we will share.
Okay, sir. Okay, thank you.
Yes.
Harish sir,
Yes, sir.
because I think participants are eagerly waiting for the feedback as well as the MCQ question. Please share both the feedback as well as the test questions.
Sure, sir. Sure, sir.
Okay, thank you.
Sir, feedback form already we are sharing in the chat box. Now we are sharing the test, sir, test link.
Yes, now the test link has been shared. Please finish it within 9 o'clock. So if anybody want accommodation, please let us know as early as possible. And I again thank to all the participants for actively participating in this online sessions for 6 days, for 2 hours each day. I know it is really not really comfortable for the faculty members, but still you have attended and you made these 6 days very successful for us. And I also hope that you actively participate in the offline session also, and you make this FTP a grand success. And thank you, and all. Sampath sir, anything else to share with the participants?
No, sir, but we are waiting another 10 minutes because the link is in the chat box. If we end the meeting, then they can't
Yes,
able to click
yes,
the link.
we'll wait for another 10 to 15 minutes. If there is any queries from the participants,
Participants,
please
they can
let
ask.
us know.
Yes, sir. Participants, if you have any doubts regarding the offline sessions, okay, including accommodation or anything, you can ask.
So Ankit sir and Arun sir, thank you, sir. Thank you. Participants, you have any queries, please let me know within a 10 minutes, because after that only you have to fill the feedback and the MCQ questions. There will be no queries. So before 10 minutes, if we are getting any problem with respect to any issues or problems with respect to the feedback as well as the MCQ question or a test, okay, please ask your questions.
We are arranging breakfast for the first day of offline session. So please, all the participants join the breakfast after the registration. Hurry, sir.
Sir, yes, sir.
I think all the participants got both of the links, sir. Yeah. So we end up the session, sir.
Yes,
Yes.
sir. I don't think so. Anybody is having any doubts.
Yes, sir.
So we will end the session. Praveen, sir, shall we end the session, sir?
Sir, wait for another 5 minutes.
Okay, sir. Right, sir. Right, sir.
So I request all the participants, if you have any queries, please let me know before the 5 minutes because we are winding the session.
Ravi Rayappa, sir. Praveen sir, shall we close the session, sir? Praveen sir? Okay, I once again thank all the participants. We will meet in the offline session on Monday. Thank you one and all.
Sir,
Yes,
take one snap, sir.
sir.
All the-
ತಗೊಂಡಿದ್ದೀನಿ sir. ತಗೊಂಡಿದ್ದೀನಿ sir.
Okay, sir.